Hey, great, great. Okay. Fantastic. Um, all right. Well, I mean, it's the class is thinning down, but maybe people are going to join. Yeah, we can start in a few minutes. Okay. So until then, if you guys have any questions, so if you just want to talk to each other, have a conversation, and you don't want me to butt in, that's fine too, right?
No,
But
I do have a question. So
yeah,
you're not
go ahead.
you're not
Yeah.
teaching to be next quarter?
No. Yeah. Well, what am I teaching next quarter? Am I teaching 2A? 2A?
I don't think so. I'm not sure.
Yeah, I think I'm teaching in spring, I'm teaching two sections of 2A.
Oh no.
Yeah.
I'll have to skip next
Yeah,
quarter then.
yeah. But I was actually thinking about it when I was walking this afternoon. I was thinking that you guys will probably be the last bunch of students to do my 2A, 2B, and 2C, I think, before I retire. Because well, I mean, if you want to do 2B next quarter, someone else's 2B, you can do it.
No. No, thank you.
Well, you know what? My 2B is different anyway, because it's we're not going to be meeting like this there's no formal lectures in 2B.
Oh.
Working through quests. You're going to be working through quests, and then we'll have informal meetings,
Mm.
weekly catch-up meetings. So there's no lectures like this in 2B, but it is great fun. Students have a great deal of fun working through the quests, and the community that you build. Essentially, it's like a group of students who basically just keep questioning and helping each other. And so they end up, completing all the levels, and they know each other, and they know each other's strengths and how they're able to help. It's actually fantastic. Now, I've seen 3 or 4 generations of these students now. So anyway, you guys will be the last, I think, because I'm not offering to be in spring. Part of the reason I think is because there's no demand. There's a few students like you, Rena, and some of you guys who want to do the class, 2B and 2C. Um, or many students think it's hard and difficult, and so they tend to drop, or they don't even tend to enroll. I mean, if you go to some of the, I think, discussions that students have, I think the general sentiment is that it is a hard section. If it's possible, you should avoid it. This is the craziest thing I think ever. And I tell this to all of the students: is anytime you go to college, it's a fantastic opportunity to do all the most difficult classes, because other things you can learn on your own most of the time. But you just go to all that's when you can get value for your money, and also the time. Forget the money, right? Because that time when in your life is like super duper valuable to just suck up everything. Um, yeah, that's available. Entertainment most of the time is you'll forget many of these things, but some of these things that you learn for, I think they're absolutely fine. This is the best time, like kids learning language, right? I think it's all right. Anyway, enough of that. Yeah, no 2B next quarter, unfortunately. However, you can continue to go and quest, and you'll still have a community, even if you're not enrolled in 2B. You can continue to quest, and you will have a community of people around you as though you are a student. Yeah. The only thing you will not have, if you're not a formally enrolled student, is you won't have the weekly Zoom meetings that we have. Again, it's not like mandatory like in 2A. We get together, and then and it's not, sometimes only 4 or 5 people turn up at these meetings. But in previous quarters, a rich group of people, like 10, 15 people, used to get together and talk about problems, quest solutions, interesting twists to some of these quests. Uh, Excellent discussions. If you go back on our YouTube channel, you can see these discussions. So some quarters it tends to go down. So if you guys have a good community, you can just keep going. And if there's more than 20 people interested in enrolling in my section of 2B and my section of 2C, I believe that you can always make a case to Foothill College, saying, well, there's 20 students here who are interested in enrolling in this class. Can you create a section? Because I think 20 is the break even. Below 20, then it doesn't make sense for Foothill to offer a new section. So I think 20, if you can get 20 students of who want to do 2B or 2C, I'm happy to, yeah, they'll ask me, and I'll say, yeah, I'm happy to do that. Otherwise, yeah, even otherwise, I don't want to offer 2B and 2C like that, because if I do that, a great deal of students just come in without even knowing what they're getting into, or or they might have done a very, very non-demanding 2A and not haven't gotten the fundamentals in place in order to tackle the harder problems in 2B and 2C, and so many of them drop. And so I can teach a lot of students, not more, a lot more than 40, which is a limit, the state limit, right? I can teach more, but 40 is the limit that Foothill puts for every faculty member. But I get something like 20 after half the class drops, and it is very um, low efficiency. Computationally, it's a very low efficiency to offer this class. I think. Yeah, I think the more efficient thing to do is just people who are interested should just go ahead and quest, because that's what they'll do anyway. Uh, uh, as you get into 2B and 2C, you will actually find that you don't need hand holding from professors as much as in 2A. Well, not that you need hand holding in 2A, but really, if you think about it, most of the time I'm coming in to help is just with C++ syntax and things that are done differently in C++, or if you're completely new to programming, showing you one new way to do things. But all of this will just get ingrained in you at the end of 2A, I think, for most people. So when they go to 2B and 2C, you don't actually need anyone to tell you this is what you need to do. Most of the time, you'll figure out the issue if you are patient and trust yourself. And I think in almost every situation that I look at in the Reddit, or people just caving in or giving up too soon, they'll either get a solution from Reddit or from asking some of their friends and relatives. But if it's a life or death situation, yeah, I can understand. You got to get this and then move on to something else. But if it's a matter of learning something, then you got all the time in your life. You shouldn't really ask for the solution at all, right? Yeah, I think that is the better approach. Anyway, that is just my 2 cents. Yeah, I'm happy to teach anyone everything I know, okay? It doesn't even have to be computer science. Anything I know that has been valuable to me in my life, and I'm happy to, share all of the secrets anytime anyone is interested, okay? So, and I have time. It doesn't just have to be during 2A. You guys get together, a group of you, and say, well, we'd like a lecture or a class on this. I'm, yeah, happy to do this. Even if it's something very deeply technical and professional like AWS cloud. I've taught this in class. I've CS55A, when we taught this, I've done if there's cloud skills, or research into machine learning problems. All of those things I can help you get, and get started. Okay. Anyway, enough of that blabbering on. So I have an interesting idea to try out today. Today we're supposed to be working on functions, okay? And I think we'll start now, okay? What time is it now? Yeah, 6:08 p.m. Well, Rena was the only one who had a question. Nobody, does anybody else have questions? Everybody should switch on the cameras, okay? Anybody else have questions?
I have a
Yeah.
question. Oh, you go ahead.
Who is this? Oh, Ray. Yeah.
I have questions for the course setting. I know you were talking about the spring festival. I'm sorry, spring quarter.
Yes, yes,
Uh,
spring quarter. Yeah.
how about summer quarter? Do you have any plan for summer
2A,
quarter?
2A, 2A.
It's still 2A.
No, actually, you know what? I may offer 2A and 2B in summer. Hey, that is so good. Okay, but it's 6 weeks, not 12 weeks. But if you're okay with that, I can offer summer CS2B. I think that is usually more successful than a regular 2B. Sometimes in the last couple of quarters, I think, in terms of the strength of the class and everything. Yeah, I can offer 2B in summer.
Oh, okay. Any plan
But
for
even then, I'm offering 2B for sure. I think fall next, the fall coming up, fall
Okay.
24, and then I'll offer 2C. I think that'll be the last time. I think in winter 20, the next year, same
Next
time.
year, same time. Okay.
Yeah.
I
Yeah.
see. All right.
So
Thank you. Yeah.
yeah, it should be
Yeah,
fun.
good to know. Thank you.
Yeah, cool.
Yeah, I
Yeah,
have a
yeah,
question.
we'll code something that will also help you in some of the questions that you've posted on the Reddit. Okay, so I think it'll be fun. All right, okay. Any other questions? Hey, Wendy, Seth, Josh, Alan, and Ariana, you should also switch on your cameras. Okay, and then we can get started. I think who was it that coded last class?
Wait, I have a question.
Yeah, sure, Dre, go on.
Yeah, oh, I forgot. Where can we find where the quest to do? I forgot where we can.
What quest to do?
The quest, like when, like the due dates. I forgot where we can find that.
Oh, there's a picture on the dates. It's by weeks. Never mind.
No. I'm sorry. What is it? Sorry.
When each quest is due, like
Oh,
what are the
when
dates?
quest is due.
Yeah, I just been turning them in.
Yeah. No, that's what Rena said is the right thing. That picture. That
But I
picture.
think it only has the week in
No,
there
and
and
no. It
a
actually
day too.
the second row should say by end of day of something like Jan 28.
Drea, there's a link in the chat. Ellen just
Yeah,
sent
the
a
link that I
link.
just uploaded, it shows the date right above our quest due.
Yeah, I see it now.
Yeah,
So
it
like
should-
I think this week's is Zebra, and so it's due on the 11th.
That's right. Yeah. Thank you, Alan.
Awesome.
There you go.
Yeah. Hey, Alan, it looks like grayscale. I thought you had a grayscale camera, but I just saw the red color on your t-shirt, so it must be, uh,
Oh yeah, it's just really dark in this room because I have the windows covered and like
I
this
see.
like
But
measly
the
little
red
light. Yeah.
wavelength. Yeah, I think the red
Yeah.
is strong because even your headphones and the red color comes through.
Oh yeah.
Great. Okay. Fantastic. Thank you all. Hey, any other questions? Dre, you good? Dre, are you good now? All right. Okay. Great. Hey, who coded last? Was it Paul? I actually forgot. Who was
It's
last?
me. It's me.
Oh, right, it was Chloe.
Oh,
It was
yeah,
Chloe.
It was Chloe.
Yeah, that's right. Yeah. All right, Chloe, why don't you nominate someone and then we'll go from there. And I'm thinking what we'll do is since you guys were so crazy about spreadsheets and all, okay, so I think we'll write a program today that will use functions and also hopefully touch upon an issue that may be the source of something that is bugging Roy in her, block on, is it quest number 4? Yeah, quest number 4. You posted something.
Me?
Yeah.
Oh,
Zebra.
it's Zebra, I think.
Yeah. Okay.
Yeah.
Fibonacci and stuff like that. Yeah. Okay. So yeah,
Yeah.
I think we'll do something today that maybe you'll find useful. Okay. Great. Chloe, go ahead and nominate someone.
I would nominate Rena.
All right. Okay.
Okay.
All right. Take the screen and what we'll do is go to online GDB and then we'll start with the comments. And at the top, we can say a class code for February 6th. February 6th. Hey, you have, I have to share, do the, share, allow multiple participants to share. Okay, now you should be able to share it. Yes?
Let me see. No, okay, give me a second. Oh no.
What happened? What happened?
Wait, my stuff is okay. My browser froze for a second.
Oh boy.
Yeah. Okay. Open system preferences. Okay.
So while Rena's getting ready, so what I was thinking we'll do today.
Oh,
is
it
we'll
says I
write
need to quit and reopen. I'm sorry.
No, don't worry. If you do 5 minutes or so, I think, can you get square it off and just yeah. Okay, cool. No worries. Okay, so while we're waiting for Rena to come back, well, I see. Well, I'll be talking her through it, so I'll talk to you guys about what I want to do today. Is I think someone brought up this issue of push front and push back, or did we talk about this last class? Yeah, push front and push back. Okay, so I was thinking.
I think we only have the pushback. Didn't see anything about push front.
Oh, there is no push front on a vector. Yes.
I actually want to ask, are we done with vectors? Because I'm still so confused on those like drawing stuff.
What are you confused about, Roy?
Like I forked I think the program Wesley shared in the forum, but I'm still have like no like bigger picture on what we're doing and how we make this
For the vector, yeah?
Yeah, for the vector, like the
How about this,
bigger
okay?
picture thing.
How about this today? Now, why don't we, who's coding, by the way? Yeah, Rena, when Rena's back, okay? So
I'm
how
back.
about, yeah, thank you, Rena, okay? So how about this? So what we'll do today is when we create we'll write a bunch of functions which are going to take a vector and take a value and push it in that, in other words, we are going to write our own push back and push front functions. Is that okay? And that will give you a very good idea of what's actually happening inside the vector too. Rui? Hey,
Sorry,
Rui,
it's muted.
Rui,
Yeah,
Rui.
it's good.
Yeah,
It
it's
will be
good.
very
Okay.
helpful.
And if you have any questions about how a vector works, as we're doing this, you should just feel free to ask. Yeah. Okay.
Okay.
All right. So
Thank you.
all right. So on the next line, you can say we'll experiment. Today, yeah, we will experiment with writing push front and push back operations on a vector. Okay. Our own. Say our own push front and push back operations on a vector. And on the next line, you can say the library only provides push back. Why? Okay. And so you can say research and discuss why. I think that will be a good starter post, or or a good excuse for someone to make a post saying, hey, I did some, we talked about this in the in class, and I did some googling around and I found this information. It's very interesting. Yeah. And I think this is all goes to the heart of computer science, really, right? So when you look at the vector as a data structure, and ask, hey, you know what? This is a vector is a container inside of which you can put stuff. A list is also a container inside of which you can put stuff. But a list has push front, but a vector does not have push front. Yeah. Why is that? Why is that? Why is one? And all of those are related ultimately to a computer scientific way of thinking about things, meaning that we want to do everything as efficiently as possible. And so, or at the very least, make the inefficient operations difficult to access, meaning that programmers automatically know, right? So to stay away from these things unless you absolutely need them. So that's what we're going to do. All right. So here, so let's do the standard thing. Hash include IO. That's all? Yeah. Research. Yeah. Great. And you can also say research and discuss, right? Many people don't do
They just research and stay silent.
Yeah, research and discuss. Okay. Add a research and discuss after the word research. And by the way, here's a tip. Here's what I see in the questing also. Many people are just posting reflections at the end of the week. However, I have seen that they are questing and they're stuck. And they come back and they keep banging the head or finding this, and they get through the quest and they only have time for the reflection. So I think the easiest thing to actually build up is when you're stuck and say, all right, I'm going to stop now and take a break. I'll come back to it tomorrow. You got to do it at least once before the deadline. Yeah. So when you do that, you're going to say, I'm going to make a post saying, hey, well, I tried this and this is where I'm stuck. If you guys have any ideas, let me know. Otherwise, I'll take another crack at it tomorrow. Okay. So that gives you one more post. And then in your reflections, you can say, I had that post. And if nobody answered and you found out yourself, and say, yeah, actually, I realized what I was doing or something like that. Yeah.
I was about to do it a few times, and I'm like, I'm gonna give myself a little bit more time, and then I would finish it and forget about it.
Yeah. See, that is a big risk. That is the
Yes.
biggest risk. Yeah. So because and not only Rena, right? I think other people have said that too, saying that they're about to push the button saying post it, and then they realize, oh my gosh, I know what the thing is. I'm not going to post it.
Yeah, and it feels like it's like some stupid mistake, and posting about it like makes you feel kind of stupid too. I'm like,
no. Unfortunately, I think we have to somehow disabuse all students of that notion, okay? Because I think that this whole idea of stupid, I think, is 99% of the bugs that we will encounter as programmers, professional programmers, are stupid bugs. Okay, I can guarantee right now. I can guarantee that for any of there are stupid bugs, and you will get to the bottom of yourself. And so I think but the stigma that is attached to it keeps it all under covers. And I think that if we all basically just said, I was, struggling with this and I found out this was a stupid bug. That's a stupid bug. And I think the stigma will go away. And then when people encounter these bugs, they will actually feel more reassured because they know that, all right, okay, so many people have gotten, stupid bugs. So I'm happy to get another one like that. Okay. Because I think bugs drive students into a little bit of a panic, especially CS2A. Yeah, it 2B, I think you're probably familiar with a lot of bugs, especially in Quest 9, you're going to be running into broken pointer errors, which you'll encounter the first time, right? Maybe you're already getting that in Fibonacci and all. But later on, you'll get into dynamic memory and pointer errors. That's a new kind of error that you will face, and it's much harder to debug. Okay, much harder than all these things. But logic bugs can also be subtle and hard. But many of the logic bugs are easy to, as composed to pointer errors are structural errors. The logic is sound, but the structure is how do you get to the bottom of that? It's you got to bring everything that you have to bear on visualizing where it is and where the links are. All right, okay. And I think in order to get there, you got to be completely conversant with the other kind of bugs and saying, well, that kind of thing I know how to solve. Okay, now I'm going to go there. This is a new kind of bug. And I think the reason why many students get put off when they get to question number 9. In fact, if you look at other sections of CS2A, many other colleges too I've seen, they get all the way to pointers, but even maybe introduce linked lists, but they don't emphasize that enough. And so many students actually go through CS2A and pass it, or maybe even get it an A without knowing about pointers or how to use pointers wisely. And but pointers actually is the thing in C++ where you have to practice a lot. It's not just knowing that pointer is an address, and you just need to practice a lot so that you get a intuitive feel for what a pointer is. And so that needs to be brought in earlier. And so students, get a chance to practice that more. And so by the time you get to 2B, you know that, this is how you can create structures in memory, and abstract structures really, because they're not physical structures. They're just in bits and bytes, but, all links are pointing to the right places. So it's a structure. And, but if there's a bug there and my logic is correct, how can I fix that, right? So you got to come to a mix of these two. And if you don't know whether your bug is in your logic or your structure, then you're screwed. But if you know that your logic is sound, right? So you got that button down first, then you can use that to figure out structural bugs. So you got to be really sound here before you go there. So that is a mistake, and that I think a lot of my 2B students have faced, because when they come into 2B, they need to be already conversant with pointers. That's why our first quest in CS2B is, pretty much the same as CS2A's 9th quest, which is to do with pointers. But lots of students don't do it. So we got to get them to do it there in the first week. But after that, it is all, one data structure after another, because it's just, and it's not just, we just need to know all these different kinds of data structures. I think that, first of all, nobody can actually teach you all the possible data structures out there, right? Or if you want to be a musician, nobody can possibly teach you every possible song out there. But I think, the good professors or the teachers that are through generations have selected a few of these points in space, such that if you just learn these, then you can extrapolate correctly, break through the event horizon and go to the singularity, right? So get to the emergent structure that is actually driving all of those. So if you work through your math examples, then these problems, if I work through these problems, it gives me a very good feel for the surface, the surface that you're trying to infer. And so I don't know where we're going with that. But the 2B certainly requires that level of dedication and insight, I think, and a lot of students do miss it, because I think the preconception is that it should be easy, and programming is just another thing that everybody does. But no, putting things together is things that everybody does, and you can do that very easily, and it is passing under the name of programming, right? But in order to be a computer scientist and a programmer, you got to learn some of this theory too. And I think that is where the perseverance is not being rewarded as much as it should be, right? If you stick to it and get to the bottom of this, you'll actually see that it rewards you, right? It's just like anything. If you just enough of this spiel. Okay, let's get into the coding because we are losing time. All right, yeah, wow, it's 6:25 already. Okay, all right, so here's what we'll do. Let's do a all right, so let's create a, all right, let's create a main. And in our main, I'm trying to imagine what we want to do, right? So we want to, and we'll put a comment there. We'll create two vectors. Okay, we'll create two vectors. As we're going to build it up step by step. Okay, all right. Right. So yeah, vector, and say vector int, all right? Vector int, vector of int. Yeah, thank you, Rina. Okay, so what? Hey, Rui, you said you are a little uncomfortable with vectors and not familiar enough with the vectors as they are, right? So are you on the same page with us so far? Vector int, meaning I want a vector of integers, is a contiguous block of memory in a space in memory, right? Which can hold integers. Where's Rui, by the way? She's gone. Oh, there you
Yeah,
are.
I'm here.
You good so far?
Yeah.
Okay, so you got to speak up and say stop, rewind. Everything is okay. Yeah.
Yeah, it's good.
Great. Okay, so vector int and say my vec, right? My underscore vec, right? Something like that. All right. A semicolon there. All right. Now on the next line, one more blank line. Yeah, and then start a comment and say test test our own push front operation. Okay, push front operation. No, push underscore front. Yeah, push underscore front. And in fact, what we'll call it is my underscore push front, because there is already no. We're going to call it a function, right? It's not a method. Yeah, it's going to be a function. Okay, good. Okay. All right. So now here are a couple of interesting things are going to happen here. And one of them is that we are going to pass the vector by reference. Actually, this is an interesting thing. What we'll do is, before we get to this push front and push back, if you guys are okay with this, right? There are two things that we talked about last class, and I completely forgot. I'm sorry. This is passing by reference and passing by copy. And I think a couple of you mentioned it in the Reddit post too. And someone did some research into the ampersand, and hey, this is what the ampersand means. Was it Chloe or Rui or someone? One of you posted some information about passing by reference. Yes?
It's me.
It's me. Yeah, that's right. Thank you, Rui. Okay. So if you're okay with this, here's what we want to do. Let's try and create two functions. In one of those functions, you're going to pass the vector by copy, right? Both of those functions do exactly the same thing, but one of them, the vector, and they both take the vector as a parameter. And in the process, I'll also talk about what passing by parameter, how a function calling and all of these works, right? And this is the part I actually forgot. I mentioned in the announcements when I say, posted it, that I just wanted to get into some of the detail of what happens in the background when you call a function, because that part is, sometimes it's left out in the books. But chances are that you're probably also enrolled in CS10, which is computer architecture. So you'll be learning that on the side around the same time.
No, I had to drop it.
Oh, you had to drop it?
Yeah, because this class takes a lot of time. I didn't believe you at first, and I'm like, I cannot do both of those at the same time.
But CS10, the computer architecture course, goes into some of the detail here, and you'll be able to relate to this, right? So hey, this is what a function call is, and so on and so forth. But we'll talk about all of those things today, right? Whether you're doing that class or not, it'll be useful, right? So here's what we'll try and do. Okay, Rina, I'm so sorry. Can you go to the top again? We'll just modify the comment and say we want to compare the performance.
The second line, or just
actually,
add more?
Get rid of the 2 lines and create 2 new comments. Okay, I'm sorry, we wasted.
All good.
4 minutes. I think we wasted about 4 minutes working on it.
Okay, yeah, we will compare.
We will compare the performance of 2 functions which do exactly the same thing, but one takes a vector passed by reference, and the other one takes a vector passed by copy. Now, does everybody understand what the difference is between the two? Rui posted that before, but when we write the functions, I'll get a chance to explain it. Passed by reference means you're not going to create a copy of the whole thing. You just say, hey, here's the whole thing in memory. Just go ahead and do it. Here's the address. You're just passing the address. But passed by copy means, right, you don't send the original. You make a copy of the original and send the copy over. Now, making a copy is expensive, right? But this thing will measure it and, give you firsthand experience of, saying, hey, passing by copy is so much more expensive because it takes more time for the same, for doing the same thing. Yeah. So we'll get, firsthand experience there. All right. So put a blank line after that, I think, and then we can go into the function. Right. So in main, what we want to do is, all right, now well, let's define the very first function, okay? Let's define the very first function. Say, thank you so much, okay? Say int space, select random element from vector. Oh, so select second element from vector, right? So some element from the vector. I think that is a good
Second? Or some?
Second, select some element from the vector, right?
Some. Okay.
I didn't want it to be the first element for some reason. I was thinking about it this morning. If actually, you know what, is a very interesting discussion point. Should it be the first element or right? Yeah, let's just say select some element from the vector. All right. So the parameter for that is vector int, and then space, and then ampersand, right? My underscore vec, right? Or just say vec, just say vec.
Just vec, okay.
Yeah, all right. So now inside of that, say return, return space, vec square bracket.
Square.
Yeah, square bracket. Vec dot size -1, okay? Vec dot size, no, actually, no, what if it's 0? Actually, you know what? You can say return vector, no, just return vec dot size -1, vec size -1. No, there is no vec square bracket, I'm sorry. Yeah, that's what I meant. Yeah, vec dot size. No square brackets at all.
Oh, just the thing
I'm sorry.
itself. Okay,
okay. I think that'll
size what?
Open, close. Yeah, open parentheses, close parentheses. And then, I don't know, just say +1. Actually, you know what? I was thinking of an expression that if suppose we do give it a vector that is not size 0, we can be sure to get the first element. All right. You know what? Instead of vec dot size, just say vec square bracket 1 for now, and we'll make sure that the vector is never less than 1. Okay. So in our tests, that's a square bracket and a semicolon after that. Right, and then delete the blank line after that, and let's put a comment on line. Go to line 8, and then enter to the next line. Put a comment, right? This is a dummy function that returns the second element of the vector. Yeah, second element of the parameter vector of the vector parameter. Note. On the next line, you can say note, make sure that the vector has at least 2 elements, when calling. All right, now what we want to do is create exactly the same thing, right? One more of those functions. Now, one more of those, exactly the same thing. We'll have to call it something else. What is it? Select some element from vector.
Select another element.
No, you know what? Another may work, but I think what we want to do is select some element from vector. The first one is by copy by reference. Yeah, right. So after vector, say by copy. So underscore by underscore copy, and then this one will be no, that one is by reference. Vector by reference. Yeah, I think that is the right thing to do, right? The right name. And this one is just going to be by copy. All right, now there is a difference between these two functions, right? And it is worth going into. Copy the whole thing, except there's no ampersand before the vec. Yeah?
I can type it.
Okay, right?
And we're still returning the second element, right?
Yeah, second element, and then I put a note above this function, a comment saying it's exactly the same except that the vector is passed by copy, not reference. Exactly the same as above. Now, they do exactly the same thing. Yes, as far as the behavior of these functions are concerned. Now, I want everybody's agreement here before we move on to the next step. Right? So I'm claiming that as far as the behavior of these functions, regardless, if we don't, if we don't consider the time it takes or the efficiency with which they do the job, the behavior of these two functions is identical, right, to the caller. I say, here's a vector, give me the second element. Yeah, and they're both going to do exactly the same thing. You don't know what's going on behind the scenes. Yes or no?
Yes.
Yes. So everybody's okay with that. Yeah. Okay, great, great. Okay, so now what we want to do is we suspect that even though they're doing the same thing, one of them is doing a much better job than the other. Yeah. And
Probably.
yeah, and the reason is because the one that says, by copy, when you give it a 1,000 element vector and say, give me the second element from this vector, by copy is going to take a copy of that entire vector, 1,000 of those integers, create another copy, give it to that function, and say, what is the second element in this copy? That is the second element in that element, that the original vector too. And it's going to, so that copying process is wasteful. Yes or no?
Yes.
Yeah. Okay. Now, how can we get around that copy? So one way is to, there's, you can do this in other languages too, but in C++, it's very clear. And I don't think this is a feature or that's found in many other languages. Essentially, it says, here is the original. I'm going to give you the original itself. So anything that you want that you would have found in a copy, you would find in the original too. So that is called passing by reference to the original instead of giving you a copy, right? And it is a powerful feature because when you come to big data, huge amounts of data, you can't afford to copy, the whole thing over. You're just going to get, and even if you don't have explicit this kind of ampersand notation, people get around that by saying, here is an object, and here's a pointer to the object. And you can, in any language, even in Python or other Java language, which don't have passing by reference, you can say, here's an object. I want to give you the original object, but I don't want to give you a copy of it. So I'll give you a pointer to the object in memory. So you can get a copy of the pointer, which is only 4 bytes, but what it points to, that's the original. Does that make sense to you guys, right? Even if you don't have passing by a reference, which means I'm going to give you the original, I could have the original and say, well, you know what? I'm just going to give you a pointer to the original. I don't care if the pointer is copied, right? My pointer could be different from your pointer, but the value of those pointers is exactly the same. They're both pointing to the original.
Mm-hmm.
Yeah?
Yeah,
so
sounds good.
Yeah. So, but it takes a little while of noodling around, say, hey, this is what it is. But once it clicks, it's very simple. I can tell you, it is one of the simpler concepts. So passing by reference, essentially saying, I'll give you the original. Now, there's one thing you got to be careful about. Now, I think it's an important feature. It's probably in the midterm too. When you pass the original to someone else, that function immediately becomes, beholden to the integrity of whoever you're calling it, because you're giving it the original object. Who knows, that person may mangle it, that person may change it, that person may change the second element too. Yes.
Yes.
All right, so how do you prevent that from happening?
Well, then I would pass by copy, I think.
Yeah, you can. All right, okay, you can.
If I know that someone can mess with it.
Yes, copy is expensive, isn't it? Copy is expensive. Yeah, okay. So yeah, so it turns out there is a way to do it. And the way you do it is by, where is that gone? All right, so pass by reference. Okay, go to line 11 and go to the before the word vector,
Mm-hmm.
right? The second vector.
Professor,
Yeah. Oh no, but after the parentheses. I'm sorry.
Professor,
Oh yeah. Okay.
I just want to confirm something,
Yeah,
just like from my understanding. So vector by copy would be when you basically copy the original vector and then you use it. So like if anyone, like you said, were to change it, then the original vector wouldn't be changed.
Yes,
Just be a copy.
exactly. But if
Okay.
if you pass by a reference, if someone was to change it, the original gets changed.
Okay, and that's what we're
Yeah.
trying to solve, how to not change the original while using
Yeah.
reference. Okay, thank
Right?
you.
Now, the thing is, the reason I'm belaboring this point is that it's actually very important to understand the value we're getting out of this from the compiler, because by inserting the word const, C-O-N-S-T, right? Write the word const. Okay, it's actually very important, and a lot of people overlook this. But this word const means a lot to the compiler. It actually tags that that parameter vec as a const, meaning nobody is allowed to change it. Now, it is very simple for in this particular case. We say, well, you know what? I'm just returning this value. I know nothing is going to happen to vector, right? It could be const. I don't care. What happens? The thing you have to imagine. What happens if instead of just returning a value, I called another function and gave it vector, right? So you delegate to someone else, and that person delegates to 5 other people. Yeah.
Mm-hmm.
And then, it branches out all over the place. Eventually it gets to the right place, right? But it branches out all over the place. Now, this guy is const, and he's just, floating around with so many unreliable, I don't know, right? You don't have control over all these things. So, so if you're going to link your code into, make it available on, as a library function to the whole world, right? Then you can't afford to have these loopholes, really. So by saying const, the compiler has your back for you. Now, what happens is that by saying const, now we're going to compile this and find out what goes on, okay? So instead of, but just before the word return, right? Just before the word return on line 12, right? Yeah, hit enter, right? And go to the first line, and say vec square bracket 0 equals, I don't know, 0 or something like that, some random number equals, and then put a comment on that line, Now this, I see, yeah. Now this will prevent the code from compiling, right? The compiler will complain that you're trying to change vec, but it's marked as const. Now, in this case, we don't appreciate, this thing because it's obvious to us. But if you consider a function that calls many things, right? The compiler has your back because it knows that this guy is marked as const. So regardless of this guy passing hands, like, the Bombay tiffin box or lunchbox thing, right? Passing, changing, eventually, right? It goes there. But I know that this guy's not allowed to change at all. So it'll actually track everything down this complex tree and make sure that nobody ever that gets that, value will change it. Now, that is a very valuable service that you will get to appreciate when you write, code with other people, lots and lots of big library code. You'll find that, I'm going to write a library function, and these are the things that I'm going to pass by, reference, and but I don't want anyone to change it. And by doing that, your code also becomes more portable because it won't be used in all the wrong situations. And then, something breaks because of what you have. All right, anyway, let's not get into that. All right, so all right, now we have these 2 functions. These are the 2 things we're going to time, right? So let's go to line 23, right? And then instead of my vec, all right, instead of my vec, after my vec, open parentheses and say, actually, no. Right. So the open, we'll do loops, right? So enter one more time after that. After at the end of the line, go enter. I'm so sorry, Reena. All right. Just
At the end of the line.
Yeah. Enter. Thank you so much. Yeah, getting rid of the parentheses and all. Thank you so much. All right. So now we'll put a comment there. We'll put a comment there. Now here's what we're going to do, right? We're just going to create a large CSV file.
Okay.
Right. Of we are we're going to print a large number of rows, of the following form, right? Right, on the next line,
Ooh.
of the following form. Yeah, no, form, FORM. Yeah, right. And on the next line, we'll say, more on the comment, right? It's going to say size of vector, right? So you say n, capital N, comma, and then time t underscore ref, comma, and then t underscore copy. Right. All right. On the next line, you can say where n is the size of the vector. Anybody find any of this unclear or confusing, you just speak up. This is what we're going to produce, and you'll actually see what when we do the loop, right? So n is the size of the vector, comma, t ref is the time taken, is the average time taken to call. On the next line, you can say the function on line 11, right? Function on line 11 with the vector as a parameter.
Or should I just copy the name instead of
Function on
publishing?
line 11. Yeah, all right. Yeah, you can do that too.
Yeah.
Right. Yeah. And a t copy is the average time taken to call function. Well, let's hope this works, okay? I was thinking about it, and it should give us something nice to look at. All right. Okay. All right. Okay. So on the next line, you can say for.
Oh, is it
On the
code
next line.
already?
Yeah. No
Okay.
comment. You can just say for.
Okay.
We're doing a for loop, okay? For n equals 10. Yeah, I put spaces on each side of the equals. Yeah, all right, semicolon, right? And then n less than, let's go to a million, okay? 1,000 times 1,000. No, actually,
Wait, oh, actually, okay.
Yeah. Actually, there's a solid reason I say that too. Because as far as the compiler is concerned, they don't care. The compiler will change that into 1 million.
Okay.
But for humans, it's a whole lot easier to know that's a million. Rather
Oh, fair enough.
Yeah. All right. Okay. A semicolon, and then say n plus equals. I don't know. It's 10,000. If we do 10,000, we'll get 100 lines. Yeah. Okay. N plus equals 10,000. Yeah. Okay. All right. So and then curly brace at the end. We'll go into the the body of the for loop. Okay. All right. Now here, what we want to do is what is that? I think time.h. We need to hash include time.h at the very top, because we're going to use the clock function. Yeah. I'm going to use hash include time.h. And then within angle brackets,
Wait.
And then, great. So what do we do? All right. So we want to time the first one. Yes. Okay. All right. So I think this is what we'll do. Right. So clock underscore t. No, I think we'll just say, double, right? We'll just say double. I think we used double before and it worked, right? Double space. No. Double space TS1 timestamp 1. TS1, yeah. Equals clock, and then double on the other side. You want to cast it to double because it's going to return clock t, right? You want to turn that into a double, right? And open and within parentheses you can say clock, and then open close. Now what that does is call the function clock, which returns the current time in milliseconds of that clock, right? And it's some weird type, maybe it's a long integer or something like that, and that's converted to a double and it's assigned to TS1, right? So on the next line, you can say time underscore function by reference, time underscore function by reference, and then pass it the value n. Right now, this is very ugly code, really. And that's because we're just winging it and talking about it off the top of my head. But eventually, you guys will probably be able to polish it and come up with a much better way of doing this too. Put a comment on that line. Right? This function will call what is that? Yeah, that function. Yeah, there you go. Select
This one?
by reference. Yeah. We'll
That's
call
a long name.
Yeah, okay, I just say F1 or something like that. Just say F1 and you can define it later, right? Yeah, F1, we'll call, yeah, by ref.
Can we just
We'll call
this?
a large number of times. We'll call a large number.
No, I think this is not clear enough. If we're not gonna add anything on top, I'll just do which one is for reference? Line 12. Go function.
Yeah. Yeah. All right. Now, I think there was one more thing I wanted to do. By reference. And it's going to call and. Okay, all right, and then say after that, say double TS2 equals double plot the same thing again, and then we want to find the duration. While you're doing that, I want to think about the other thing that I wanted to do. Yeah, and then the duration is going to be double duration. Double duration equals TS2 minus TS1. Oh, yes, we forgot to size the vector. All right. So no, that's okay. So inside of the for loop, on line 31, hit enter at the end of line 31. Yeah, and then start a comment. Size and say size the vector and fill it with random numbers. All right, size the vector and fill it with random numbers. Now,
TS2 and TS1 are not written the same way in the for loop.
Oh yeah. Thank you.
Yeah.
Yeah.
Typos.
I didn't realize that.
That's how bugs created.
Yeah. But the IDE will look out for us. All right. So where is it? Where were you before? Yeah, size the vector and fill it with random numbers.
But in the for loop, that n needs to be categorized as like an int or a size t or whatever.
Which oh yeah. Size.
Like this?
Yeah, you can say size t.
Size t?
But yeah, int or size t or whatever it is good. Right. So all right. So now on line 32, hit enter on line 32. Right. Now you're going to say my vec dot resize open parentheses n close parentheses. Okay. Now this is something that you can look up. It's very useful. It says here's an array. It has no elements in it. It's empty. Now dot resize is a method that will take that array and then blow it up to the requested size. Now, if the array was already big and I said resize to 10, it'll just chop everything down. So it'll give you the array, which you're calling it on that array, that vector, and it'll size it to the exact value you wanted. Now that is outside of our timing loop because inside of resize, you need to pass the value n, inside the value n, right? Right. So on the end, hit enter one more time, right? One more end. Now you can say for j equals 0, j less than n, j plus plus. Do we need to fill it with random values? Just give me one sec, okay? Do we need to fill it with random values or not? I don't think we need to fill it with random values, okay? It'll just increase the runtime of this program and it'll be wasteful. Just get rid of that line, but leave the blank line there. Get rid of the blank line. Yeah, right. Leave the blank line, get rid of it. Right. And remove that and fill it with random numbers, right? Resize the vector. Okay. All right, okay. Now, all right. Now you want to copy lines 35 to 39. And then the whole thing copy after a blank line, put the whole thing back.
After blank line?
Yeah, no, but put a blank line after that. Put a blank line after that. Yeah,
Sure.
and then copy the whole thing again. And now you want to change, get rid of the double before TS1 and TS2.
Am I still casting it to double?
And then, well, you have to cast it. Yes, you have to cast it. Yes, and also double duration. Go. And in fact, because we want to keep it symmetric, so what we can do is instead of declaring double here, inside of the for loop, as soon as you get into the for loop, on the first line, say double TS1, comma TS2, comma duration, right? So, and then you can get rid of the double from here too. And it'll look nicer that way, I think. And then blank line, semicolon, blank line after that. So we keep the declarations separate. All right. Now, yeah. Okay. Now, is everybody okay with what we've done so far? Now, we've got the two durations. and we have n, so we need to just print it out. So after that, after the last one, yeah, hit enter, and say C out, left shift, n, and then left shift a comma within quotes.
Did we want one of those to be by copy, or are they, because right now,
Yes, one of them should be by copy. Thank you so much. Who was it, Wesley? Or Andre?
it was me, it was Wesley.
Wesley. All right, thank you. Right? Okay. All right. So and then left shift T we got duration. No, we got the same thing there. We gotta say duration one, duration. Oh, I see. Duration underscore ref and duration underscore copy. Yeah. Oh, and you need the declarations up there too.
Two durations, right?
Okay. All right. Now you need to print those two and put commas between them, and then we run it. Oh, we got to write those two functions. So, pretty simple, easy functions. No, but one thing I realized was that someone said, it's things are ramping up in class, and we're writing a lot of code, and it's now I want to lay that to rest once and for all, because if you look at what we're doing, okay, we are basically copying and pasting large chunks of code. Yes, right? We write 3 lines, 4 lines, and then we just replicate it 4 times. And then at the end of the day, we end up like 60 lines or 70 lines, right? But it's nothing to be afraid of. Yes, it is exactly the same. We're writing simple programs, but the same, we're repeating fragments again and again. So there is no reason to think that we're writing a lot of code in class. If you do feel things are fast, and I know Rena has experience too, because she's posted some of these extra credit stuff on the things. So if either of us is going fast, too fast for you, you just have to say, hey, slow down, right? I think the first class Ariana was coding or something like that, and she was a little fast, and I think or at least I said, go a little slow. Yeah. So I think if anybody feels we're going too fast, you just have to say, slow down. Everybody understand where we're going though, right? So all we need to do now, you've done that? Okay, now go all the way to, we want to define those functions, those 2 functions, time function by reference and time. Yeah, so let's do that. And then, in fact, I'll do one, you do the other one. Okay, how about that? Okay.
Okay.
Yeah. Right. And by you, I don't mean Rena. Okay. Rena's going to type. Yeah, Rena's going to type. But someone else should jump in and say, "Hey, I want to make a copy of that function." Okay.
So
right.
if it's time,
I'll do the first one. Well, let's do the first one.
Is it int as well?
Oh, I see. Yeah. Hang on.
Function by reference.
Oh yeah. This is where I wanted to talk about what Rue, the problem that Rue had. Okay. Yeah. All right. So where is that function? Where are we calling that? Time to no.
We're calling it in the loop right here. This one.
I see. Okay. All right. Here, I think we'll do it. We'll do it in a way in which it'll make more sense to talk about Rue's problem here. Okay. So instead of this, instead of time function by reference, no, right there on line on that line, right? Go to the beginning of line 40, and say duration underscore ref equals. Okay, duration underscore ref equals. Right, and get rid of TS1 and TS2. We don't need that. Even variables, we don't need those variables either.
At all?
Yeah, we don't need those variables. None of those variables. We need durations, the 2 durations, but we don't
need durations, but we need, okay.
Yeah, all right. So now get rid of those lines. Get rid of those lines, and that one too, and then
this one too.
Yeah. Right, and the next one also same. Right. So we've actually cleaned up the code a whole lot. Okay, it's much nicer. All right. So now and
this
we
is gonna be
duration
copy.
Yeah. Okay. Get rid of the blank lines. Okay, all right. No, and there's 2 blank lines, yeah, above and below, so you can clean up those 2. Okay, all right. Now time function by reference. Go to the place. Go up there. Now this function returns a double. Yes, because it returns that duration, and duration is of type double. Roy, you got to say yes too, right? So that function returns something of type double. Now here's what happens. Now, when a function returns a value, or when a parameter is passed to a function, what happens is that I'm going to launch a little bit into computer architecture here. You know, what happens when the program is compiled into machine code is just a bunch of instructions in memory, one after another. So when execution starts, there is a pointer that says, all right, here's my first instruction to execute one after another, bam, 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 like that. Except when a function is called, there is a special instruction for that chipset that says this is a function call. That means instead of going bam, 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 bam like that, at that point, it's going to say, well, you know, I'm a function call. I'm going to go here. Okay, some other place. It's not going to the next location, some random location, not random location, some other place where the code of the function is stored in memory. It's not sequential. Now, what happens is that now, as soon as it starts the function, it's going to go through that function, right, until it hits a special instruction at the end of the function that says, now you're done with the function, you can go back to whoever called you. That is called the return instruction. Okay, these are part of the chipset instruction. So that is what happens when a function is called. The instructions in memory, insert one after another. All of a sudden, when a function is called, the compiler translates that into a function call, not a jump. A jump says, you know, go there, don't come back, right? There's two kinds of jumps, you know, control transfers. One is called a jump that says, you know, go to that random location, start working from there. No need to come back, but a function is a special kind of jump. It says, go to that place, do all the instructions you find there, but you'll find a special instruction called return. That is the end of the function. When you find the end of the function, that return instruction, all you have to do is come back exactly to the place where I called you. Okay, now that is the critical part to understand, because if you want to come back to the exact place that your caller called you, and so you say, call function A, you're here. When function A is done, you're going to come back here. Now, what happens if function A called function B, right? So you're going to be jumping here, you're doing your work here, and all of a sudden, function A calls some other function. So you go jump there. But when that function is done, you don't come all the way back here. You go in the reverse sequence in which you descended. Yes or no?
Yes.
And A calls B, and B calls C, and C calls D, and so on and so forth, right? When each function exits or finishes its job, it's going to come in the exact opposite sequence, right? It's first in, last out. The one that goes on first is the last one to come out. So it is exactly like a stack of plates. So the first plate to go in is the last plate to come out. You can stack stuff up, and you can pull one from the bottom. So only the top is visible at all times. So that is called a stack data structure. Now, a stack is actually a very interesting data structure because usually it is built on top of an array, which actually gives you random access. You can go anywhere in the array, like we've seen. You have a vector. You can go anywhere in the vector for free. But a stack says, give me an array, which you can go anywhere in there. But I'm going to arrange it so that you cannot go anywhere. You can only go to one end of the array. It's only the top. So you can actually grow in this direction. But if you want to go back, you want to pop the ones that you put on top first. They have to go off. They have to go off first. Yes, that's called a stack data structure. So what happens here is that when a function hits return this value to the user, that value is actually put on stack. So here is the problem that Rue ran into. So when you have a function that says, I'm going to return a double, and then you call the function and say, all right, go and give me this value. But I'm going to imagine that function did not return a double, but returned a long. Now, I actually looked into the problem that you reported and say, why did the compiler not complain? Okay, here's a very interesting thing. Now go into on Reddit to look at Rue's post. I said, well, actually, other people don't know maybe, right? If you have a mismatch in a function that says, I'm going to return a double number that is 8 bytes long. A double is 8 bytes in C++. Okay, a double is 8 bytes. A long is a long integer that is also 8 bytes. Now, the reason I think, this is my hypothesis, if anyone can confirm this and write about this, it's a fantastic opportunity, okay? Because I don't know myself, and I'll be so happy to find out, is why the compiler did not complain when Rue's code was compiled, okay? Because her function says, I'm going to return a long. Because Fibonacci could be very long. So Rue said, okay, I'm going to use a long data type to return whatever Fibonacci computes. And it's very long. Yes. However, in main, when the function is called, it says the function should return a double.
Did I see that?
No, that's what the spec says,
Uh,
right? According to the spec, the function returns a double. Fibonacci returns a double. Yes? Someone should
no,
confirm that.
my Fibonacci function return a long
Yeah,
line.
your function. No, I think in my function, when I call Fibonacci,
Okay, okay.
I say, I'm expecting Fibonacci to return a double. Yes or no? Someone should confirm this, okay? Because that is the only reason why that code could have failed. What does it say in the spec? Fibonacci returns a double, yes?
You mean in your main function?
No, in the spec, in the specification for that quest, when it says, call Fibonacci, define a function called Fibonacci, it should return a double number.
Oh, I didn't pay attention to that detail.
Okay, all right. So when
that's the reason.
I think, someone should find out, and if it's not the case, post it, okay? Because I'll be very, very interested to know. In that case, that might be a serious bug. I need to look at it, right? So, and maybe in the tester, unlikely in the tester, but someone should look into it, absolutely. So the spec says, give me a function that gives me a double. And that function, instead of a double, returns a long. Now the compiler should say, hey, this person wants a double, but you're returning a long. I'm not going to compile. Because you can't assign an apple to an orange. They're two different data types, yes?
Yeah.
Okay, now it didn't complain for you, and it worked. And it worked because I think this is my hypothesis. Someone has to come. I actually will give you extra credit if anyone can do some research and confirm this. Okay, I think it didn't complain because double is the exact same size as long. Right? A long is 8 bytes, and a double is also 8 bytes. And the compiler says, right, you're returning 8 bytes, and they're expecting 8 bytes. I'll just give it, pass it over. No. But if that was different size, if it was returning an int and that was expecting a double, I'm pretty sure the compiler would have complained because different sizes.
Yeah, I can confirm the instruction that says return to a double.
Yeah. Okay.
I'm
Anyway,
looking at it.
thank you. Who was it, by the way? Was it Chloe or Roy? Someone confirmed this. Yeah.
It's Ray still.
Right. So yeah. Anyway, thank you. All right. So I think that is what is going on. So what's going on is that you're returning a number in long format, and it is being interpreted by the caller as a double, which means it is being unpacked differently from the way you packed it. You packed it as integer in 2's complement notation. Whereas I'm looking at it as a floating point number. Now, this is very interesting, isn't it? Because it goes all the way back to data representation in week 1. And how would you explain this to someone who has not understood how numbers are packed in binary? Yeah. And in fact, Rui, if you look at the floating point representation in C++, for whatever architecture that we're using, and you look at the value you're getting and the number you're returning, and you look at the two representations, they look exactly the same, right? You just have to chop it up. This is the bit pattern, chop it up into mantissa and exponent, and I calculate that, you'll see what that value is in the,
okay.
right? So it's very interesting. Well, I'm sorry for the digression, okay? So I just wanted to, yeah. Does it answer your question, by the way? Right, I was going to do that here, but I thought, I might as well talk about it and we'll just cut to the chase right here.
Yeah, it should. I'll try again, let you know how it works.
Okay, well, you should just feel free to, talk in the Reddit and, ask questions and lengthen the conversation too. More people should chime in because these are all interesting things to talk about. And I actually greatly appreciate the the opportunity to read some of what you guys are writing. And I actually read all of them. You may think that I'm not commenting on every post, that I'm not reading them. I actually read everything. In fact, I might even remember most of your reflections. So anyone can ask me, and I do read them and I appreciate them. Right? So it's very interesting. I love to read all of those. All right. Well, someone posted. Someone just posted an interesting post. All right. Okay. So the time function by reference. Okay. All right. Here, and how are we calling it, by the way? How are we calling it? We need to pass the vector. Are we passing the vector? Oh, yeah. Pass the vector also. Pass by vector. No, on not function. That function. On line 41. On line 41. Before n, also pass vector.
Before n. So just my vec or vec?
Yeah,
or
my
what?
vec,
Okay.
comma. In fact, since you're passing my vec, you don't even need to pass n because n is the size of the vec. You can calculate that. Just pass my vec. On the next one, also pass my vec. All right. Okay. Now let's go into that function up here, and the first one by reference, right? Both of them will accept the parameter by reference because that's not being timed here. So what we'll say is, and this is not going to be by again. These are all interesting points to talk about in the forum. So I'm actually so. Yeah, all right, okay. So a time function by reference, and you say vector int, vector int, vector int, vector int, yeah, and then ampersand vec, okay, ampersand vec. Now put a comment on top, saying, why does this not have const? Okay, discuss, right? So these are, I'm just pointing out things that you can actually sink your teeth into and talk about, giving you excuses really to strike up interesting conversations on Reddit. Okay, right? Okay, right. So on the next line, all right. So on the next line, what you can say is double TS1 equals clock, no, double clock. You know, that thing that we had before. Yeah. And now we can do a for loop here. Okay. I want to do on the next line for j. Oh, actually, we didn't want. Yeah. For j equals 0. J less than. I don't know, shall we run it like a 1,000 times? Yeah, let's run 1,000 times. 1,000, right? 1,000. J plus plus. J plus plus. And what we want to do, yeah, on the next line, yeah, and this is by reference, right? On the reference. On the next line, you can say,
wait, do I need curly braces? Or is it just going to be one
I
liner?
was thinking, no, we don't need curly braces. I'm fearful that the compiler might optimize these things out, but I think we can arrange for that not happen. Right now, you can say int result equals select some element by from vector by reference, and then pass it vec. So what this is going to do, and then this is going to do this 1,000 times, right? And then, let's put one more comment on line 22. Hit on enter on one. Yeah, enter there. One more comment. This function will call our reference function or whatever it is, line 11 function. We're referring to it so many times.
If it's gonna move, it's gonna be confusing.
Yeah.
So it's 12.
You guys have got to figure out a good way of laying this out. All right. Right. Yeah. Call a reference function 1,000 times and return the total time taken divided by 1,000, right? And return the average time taken. I think it return the average time taken. I think that's much better. Return the average time taken. Okay. All right. All right. Now on the next line, after the for, yeah, on the next line, one enter. And yeah, there you go. And you can say return. Oh, you need another, double TS2 equals.
Oh, right.
Line 25. You can copy line 25 and put it there one more time at the end. After the for loop. Yeah. There you go. Now you can say return TS2 minus TS1, the whole thing divided by 1,000.0. Yeah, that is the average. Is everybody okay with that so far? Okay, it's TS2 minus TS1. Now for the other one, we need exactly the same thing, okay? Except it's going to call the other function. But in order to do that, you need to first understand what this function does. And I think it is very simple and straightforward. Yeah. And so if you have any problems with this, you should ask. And then, Rena or I or other people who have understood will be able to chime in and say, this is what it does. And it's also simple. Okay, so we'll be able to understand that. Okay, so does everybody understand how it's going so far, right? If you don't understand anything at all,
could you like quickly just go over what
yes,
this
go ahead.
exactly does again?
What it does? Okay, all right. So this is a function. When you call this function, it is going to get given a vector. Now, along this line, anyone feel unsure about anything, any statement? I'll just speak in sentences. At the end of every sentence, if anyone has any questions, just stop me and say, I don't understand. Okay, all right. So this function is when we invoke it, we're going to give it a vector. That vector is given to this function by reference, meaning, there's no copy overhead there. Yes or no? Yeah? Okay, all right. Now, what it's going to do is as soon as it gets that vector, it's going to measure the clock, saying, what is the current time? The next thing it's going to do is that it is going to get the second element from this vector by calling our function that will take that vector by reference, not by copy. And it's going to call that function 1,000 times. Yeah?
Mm-hmm.
And then, all right. And then we take the second timestamp, and then difference between the two is going to say, this is the time taken by that function called 1,000 times. So the average time taken per call is this minus that divided by 1,000. Yes?
So that will the result accumulate all of the
Oh, yes, thank you.
Yeah.
Thank you. Thank you. See, all right. Okay. And in fact, what we should do is, and we have int result. Oh, no, actually, yeah. No, that's all right. Okay, I'm sorry. I'll take it back. Okay. No, thank you. All right. Okay. So no, we actually don't want results at all. You just say void. Okay. I put int result there because I was afraid the compiler will optimize things out and shit like that, but it's not going to happen. Okay. We'll get rid of int result equals, and just say,
just call the function.
let's call the function.
Okay.
Some people, is a style you may see in other programs. Some people, when they call a function that returns a value, but you are not using that value, will actually put the word void within parentheses in front of the function. Okay, why don't you put it there and say, this is yeah, put the function, put the word void, put the void and within parentheses in front of the function.
Within parentheses?
Yeah, that word void should be within parentheses. No, void itself should be within parentheses. All right, now put a space after that.
Haven't seen that before.
Yeah, I haven't seen that in a long time, but I have seen it in some, some programmers, very nice, beautiful code. I've seen a very nice code, but some of them also follow rules to the dot. And so I think maybe these are programmers who've used other languages in which these things were strict. They say, here's a function that returns a value, but you're not using it. Therefore, make it known to the compiler that you are deliberately ignoring that value. Otherwise, the compiler won't let you pass, right? So there are other compilers that are stricter, even stricter than these compilers. You'll get a lot of red ink if you didn't put the word void there. So there are programmers who have grown up using those kinds of IDEs and compilers. And so they put the word void there, and therefore the C++ compiler also tolerates that. So you put you right. I've seen C++, so you can get rid of that now. Now we don't want to talk about that or more, but I just wanted to say that's also possible. You can get rid of the word void. Yeah. All right. Okay. Now is everybody okay so far? So this returns the average time that the function takes for 1,000 for each of 1,000 invocations. Right. That function is being called 1,000 times. And we time it, and then we take the average over 1,000, and that's what we're returning. Yes or no?
Yeah, I think I just finally got it. Yeah.
Everybody should give me a thumbs up now, okay? Everybody should give me a thumbs up. If not, we're not moving forward, okay? Rina, give me 2 thumbs up, all right? All right. Wendy, Ananya, Mazin, Andrew, Seth, you guys, are you okay? All right, Andre, off camera now. And I think Kate was okay. Okay, great. Thank you. Okay, now you guys have just got to do the other function, which is exactly the same. And that one has got to call the other function, which is by copy. And then when you run this, it is going to produce a CSV. When you run it, it's going to print a lot of CSV values. What we're going to do is copy that and put it into a Google spreadsheet. And we're going to say, plot it. Okay, you'll get two lines. One of them will be a line and the other one will be a parabola. Right? That is my hypothesis anyway, right? We'll see that happen. Okay, and it'll be fun. Irina is typing away, but nobody's dictating, right? Someone should be dictating.
I can read. I can read from above.
Oh, I see. Yes, okay. It is just the exact same thing. Well, I thought there was something different. Yeah, the name of the function.
The name and the way we pass the vector. The only different thing.
No, actually, no. We don't have to do the way we pass the vector is automatic. So, but we'll get to that when you type it. We'll get to that.
Okay.
Is everybody okay with that so far?
Everyone's so quiet.
Yeah. You
It
know,
seems
I
you're
think
so
it's partly
lonely.
because I'm talking so much. It's because I'm talking so much and then other people are not talking. We just have to figure out a way in which I don't talk so much. I think if you guys talk more, I'll just, pipe down. I just don't want, I don't want silence on the line, essentially. So if you guys are not talking, I'll just keep talking.
Like everyone
Actually,
can
even if
talk about the
Rina's just-
weather.
even if Rina's just talking while she's coding, that's fine too. Because, the airwaves are occupied and it looks like some activity is happening and people will also be drawn in and see that. Also, I've made this point before, okay? I think if there's silence, it tends to be self-reinforcing, okay? Meaning that if there's silence, nobody wants to start the conversation. But I think if there's people already talking, then people will be more comfortable with interjecting. So I think it is kind of self reinforcing in a way.
It really depends. Some people just stay quiet.
Yeah,
That's
we
it.
have to prod them. We have to keep prodding them. Hey, all right. All right. I'll try my best, okay? So people who aren't talking, I'll just keep answering, asking them to.
I think one idea to get more people talking would to be like set up like a quest type, like just give us the requirements of a program, and then we have to come up with the program, and you just walk away and let us deal with it on our own.
Yeah, I like that. Yeah, sorry, Rina, you were saying.
No. I was just laughing because it's a very interesting proposition from Josh.
Yeah,
We
we
can
did
try that.
before. It worked. Actually, it did work, right? Because I gave you a problem and then you guys were working on it and I walked away.
Oh, with oh my God, with the lines, right?
Something like that.
Yeah.
I
When we
have a
got
question.
Yeah.
So
You're asking me?
no. So in our like main function, we're passing into double duration reference one. We're passing this integer, but doesn't our function need to get passed in a vector?
we're passing the vector.
We are
scroll
passing
down.
You're using the old version of the code then.
Oh, I see. Sorry.
It was N before and then Rina changed it to back.
Okay.
Now, if I'm not mistaken, if we run it, do we have the C out and everything in there?
Yes.
Wow, yeah. If we get rid of the comment after that, it says and
This one?
return 0. Yeah, actually, what's it doing? Get the return 0 should be out of the for loop. The return 0 should be outside the for loop. The return 0.
Oh, it is inside. Oh my God.
Yeah.
How
That
horrible.
would have only run one time otherwise. All right, and get rid of the comment after that. So
Yeah, it doesn't make much sense here.
now, also, get rid of the two blank lines above
These
after
ones,
the
yeah.
cout. Actually, something. Yeah, I think it's okay. It's right.
Should we try run it?
Yeah, you can try running it. I think it should run. Hopefully.
No.
Right. Okay. Vector. Oh, we have to hash include vector. Hash include vector at the top.
Oh. Everything needs to be
No,
included.
put it above time.h because I think it is more of a C++ thing.
Oh, the order here matters?
No,
The
it
order
doesn't
matters
matter.
will include?
No, it doesn't matter.
Okay.
But I think actually someone did ask a question about include files. I think Ananya asked a question about include files. Yes. Hey, Ananya, are you here? I think she stepped out. I think in one of the posts, Ananya said, I don't understand what the include files are. And I was thinking, well, why don't we do it today? What we want to do in an include file is essentially when we have a whole bunch of, we'll get to that soon, okay? An include file, this vector include file will fix this problem. But what I wanted to do today was after we've done this, we want to do a multi-file project right here. Meaning that take these two functions, right? Line 12, cut line 20, cut line 12 to 22, cut all of them.
12 to 22?
Keep them in your clipboard. Yeah, cut it and put it after main, Oh, even the one after that, even the one, oh, just those two for now, right? You can cut it, put it after main instead of before main. Right? Now, if you compile it, it'll actually say, I don't know these two functions, right? It'll say, I don't know these functions.
Mm-hmm. Yep.
Does it say that?
Yeah, was not declared in the scope.
Right. It says doesn't know. That's because when you call the function, the compiler has not yet encountered the definition or the declaration of the function.
Mm-hmm.
So it doesn't know that this function takes this kind of argument. It takes a double, it takes a vector, it returns an integer, it returns a double. It doesn't know that. So therefore, the compiler is not able to look out for you because it doesn't know the signature of the function. If the compiler knows the signature of the function before you call it, then it can have your back for you when you call it and say, hey, you know what? It's not valid. It's not going to work because that function takes a different kind of parameter.
Yeah, but on line 15, we did this on purpose for the code to not compile when we said that first element of the vector is 0. Should I comment it out?
Oh, didn't we get an error? We should have gotten an error for that.
Yeah, we got it.
Oh yeah. Let's look at the error.
This one. But this is on
How
purpose,
come we didn't
right?
get the other errors now? Those two.
Oh, because I changed it all the way back. Before that, errors.
Oh
was
no,
the...
put it on the at the end. I want to fix that.
Oh,
By doing
okay.
something and then showing what Ananya wanted to do.
Okay.
Right. All right. Now, if you compile that, and you can, all right, and also you can fix that other error, saying, the thing that Rina was saying, const is going to prevent that from compiling because it says, you can't do that. It's const, right? So you can. Is everybody okay with that? That was the effect. In the vec of 0, we can't assign to vec because it's been marked with politics. Right. Now you can get rid of that line. You get no, I saw that. I saw that there.
This one. I'm just gonna comment it out.
Now, if you compile that, you'll only get those two errors that we can make that go away with, right. So it says the compiler says, I don't know the types of these two functions. So this is what we'll do. Now just copy the triple click on line 59, triple click on line 59. No, on the line itself. Yeah. Now copy that into your clipboard and go right to the top of the file. Under the include files, right? And then, one more, and start a comment there. Say forward declarations, and these terms that you just need to know. A forward declaration is basically just telling the compiler that, hey, in my program, I will be calling a function of this type, and it's there somewhere. Don't freak out if you see it. Okay, that's what we're saying, right? So, all right, right now, get rid of the spaces before the end. Right, and on the end, put a semicolon instead of the curly brace. Right, now copy the whole line, put it one more time, and then change the reference to copy. Right. So on the next line, we'll start a comment. Right. On the next line, we'll start a comment. Right. The above two lines tell the compiler not to freak out when it encounters calls to the above two functions. Before the compiler has seen the function bodies. Okay. Is everybody okay with this? Now, if you compile this, it'll work. I mean, work meaning it'll compile okay. It won't have any problems. Bodies, function bodies. Yeah. Now, if you run it now, I'm pretty sure it'll work. Oh, wait a sec. Are you using namespace? Or do you have hash include vector? You have hash include. Are you using
vector is here. Namespace.
Oh,
is
hang
here.
on. Hash include vector is correct. Include time.h. Oh, of course, right. Those forward declarations need to go after using namespace standard, not before. Because until then, it's it's not vector, it's std double colon vector. I don't know how you guys would have figured this out. It'll take you a long time. Frustration too, because I know this because I have been frustrated by these things a lot when I was learning these things. It is painful, but oh well, okay. It seems to have done it. Now copy the whole thing and go to Google spreadsheets or something, Excel or spreadsheet or something like that, and let's put it in there. Now here's what actually let's put let's put a header. Let's put a header on the top. So go to your main. Go to your main. Go to your main. And just before the for loop. Before the for loop.
No, before. Okay.
Yeah, at the end. Yeah, enter one more time, and then say C out left shift.
Oh wait, you mean the actual
C out left shift, and then within quotes you say uppercase N, comma. T underscore, what was the first one? T, what is the first one was ref, was it?
Yeah, I think so. We can check.
And then endl after that. Okay, and that is a header line. So when you run it now, we'll get the header. Then we copy that into Google spreadsheets. It'll just go into the right places. Then we'll be able to plot it. All right, now copy the whole thing. Oh,
it's still going, yeah. So
well, it takes longer and longer. Oh, because the vectors are getting bigger and bigger. Okay. Okay. All right, let's take the whole thing and then go to Google spreadsheets and then paste it. And then
yeah.
New, I think you hit the plus on the bottom. Hit the plus.
I have no idea how to do with it.
I see,
that was my first time when we did the grid thing.
Paste it.
Just like randomly in one cell. Oh my god.
So now it should be possible to split on comma. You should click on right click on A. It should be possible to split it on comma. Maybe it's on under data. Click on data on top. Click on data on top. Does it have split on comma? Split.
I see 2 columns.
Yeah, split text to columns. Yeah, click that. Hey, it actually worked. Okay. Think about the commas and put them on different rows. All right. Now it says that all right, now here's what we want to do. Now I'll leave this as, maybe extra credit for you guys to noodle on and, right. What we want to do is treat the first column as your x-axis. N is your x-axis as N grows. Okay. And then the time taken by the function that is the ref function, right, is your y-axis. It's going to be in green or some color. Okay. And it's going to be in a green line like that. And the time taken by the other function, maybe it's an orange line. That's going to be like that. So you're going to plot these three things using Google. And if we have time, we're going to do this in class. I want to do one more thing, which to show what to complete the thought that I started talking about with Ananya, and come back to this. Okay, so that's what we want to do with the spreadsheet. But so far, is everybody okay? We want to do one more change here. Go to the very top where you have those two functions, the forward declarations. Okay, here's what we do for include files. Okay, so go to line number 10 and hit enter. Go to line number 10 and hit enter, and start a comment there. Saying we will move the forward declarations from here into a file of its own. Okay, this was a question asked by Ananya on Reddit. All right. Okay. And you can say, you can have to call attention to Ananya here. I don't know how you do call that. Check this out, Ananya, right? Check this out as hyphen Ananya or something like that. Okay, right? Yeah, for Ananya. I think that's much better. Okay, yeah, that's great. Okay, all right. Now what we want to do is copy line 12 to line 14. Cut it out. Keep it in your clipboard and cut it out of there. Cut it out of there. All right. And instead of that, say hash include. Now, instead of angle brackets, you're going to say quotes. Okay. Quotes. Right. And here you're going to say, what did we call this function? It's called main.cpp. Say xyz.h. Okay, what's a horrible name? Yeah, helper.h. Okay, call it helper.h. Helper.h. Okay, all right. Now this is a function. This on the previous line. Now actually click on. We need to get that blue thing back again. The blue side on the sidebar on blue sidebar. How do you get that?
Oh,
Maybe click that lightning thing on the.
okay, yeah.
Not there. We want a new file. Wait 1 sec. We want a new
I think
file.
this one is.
Oh, new file. There you go. Yeah. We can get rid of the blue part then. All right. So call it helper.h. Yeah. Okay. Now paste those 2 lines. All right. Now actually put a comment on top saying put a comment top. In fact, you know what? This is where that thing with for Ananya should also be there. They say this is a file that will just this file will get automatically included in our main.cpp. Right. And here you can say, for Ananya, and then we can get rid of that comment from the other one.
Did I spell it right? Yeah.
Yeah. And yeah, go to the main.cpp. And in fact,
Just
forward
the whole thing?
the
Oh,
above
no.
2 lines. Oh, yeah. You can get rid of that one. Get rid of that line.
The whole line? The whole comment?
Yeah, you can get rid of that line, but copy that line 14 and 13 and 14 into that other thing. 13 and 14 into helper.h. Oh, the following 2 lines. The following 2 lines, not the above 2 lines. 2 lines. Tell the compiler not to freak out when we call the above. When we call the following when we call the functions. When we call the following functions, right? Yeah, or whatever. When we call the functions before the compiler, before the compiler has seen the functions bodies. Yeah. Okay. Right now, and then you can also say it is in a file of its own to make the main CPP more readable. Hopefully, this will help answer the question she had.
Oh, what was the question?
And the question was that Rue answered it saying, well, you need to include looping functions.h and looping functions.cpp. And I believe she said, well, it works now, but I don't understand what .h file is and what goes in it. And I don't think anyone answered that. I know a lot of people know the answer, but people didn't answer. But you should take these opportunities and say, hey.
No. I answered by Google, like by the Google search. I just paste like what I Google like result.
Oh, you did answer that.
Yeah.
I see. Oh, I must have missed that then. Thank you. Yeah. Because that's basically what it is. So helper.h, we've basically taken that stuff and put it in helper.h so that our main.cpp is not cluttered. When you develop large projects, you'll have lots and lots of these things. And this is a way of taking things out and making sure that the logic is tightened. Right. Now let's go back to the spreadsheet and we'll see if we can plot it.
Oh, I have no idea how to do that.
Select A, B, and C, right? Select A, B, and C.
Wait, someone said something.
Yeah, I was wondering if it would be possible for you to share your code, because I'm getting something different, so I just want to compare them.
Okay. Give me a second. Okay, how do I... Wait, where's my stuff? How do I get the chat back? Can some... Oh, okay, I got it. Okay, here you go.
Thank you.
Does someone want to do the Excel stuff? Just asking. I think Rue is better at it.
Just feel free. You shouldn't say, does someone want to? You can actually tag someone and say, hey, do it.
Do I share this stuff too? How do I share this? Oh, like that.
No, you can basically tell them to take the online GDB thing and they can run it and copy this of their own. It's not a big deal, right?
I had a question about the placement of the hashtag include helper.h. Why is that after the using namespace?
It doesn't have to be after.
Okay.
Oh, no. I think, no, it has to be after. It has to be after because in our helper.h, we're passing a vector, yes?
Oh, I didn't see that.
Oh, yeah.
It's all very contrived. really, because this is two simple functions. And in fact, go to that the helper.h, and instead of vector, say std double colon vector. Okay, std double colon vector. Double colon vector, right? And go to the line before, above that. Yeah, and one more. Enter, and say hash include vector for good measure. Okay, so it won't complain and crap out. Hash include vector. So we haven't changed the namespace to standard, but we have included the vector so that it knows about vectors, so it'll compile. So, and then a blank line after that, and then we'll say, and then say following two lines, right? The following two declarations, instead of two lines, say following two declarations. No, on top, on line 4, where you say the following two lines, say following two declarations. Yeah, is that clear to everyone?
Everyone is nodding silently. I can see. I can see
Okay, all right, okay. Well, I've seen a couple of thumbs up. Okay, good. Now, what we want to do is just go to the, and hopefully, Ananya, when you're back and you see this, say it, please chime in to say if this, answers the question you had about what goes in header files and so on. Okay, so this is basically what it is. And you can take anything and put it in header files. One of the things I've seen students do is to hash include CPP files. Okay, that is a sure path to disaster. Don't do that. It'll work, but it makes debugging and a whole lot of things much more complicated. Don't hash include CPP files ever. Okay, only header files, and don't include C code in header files unless in certain cases you'll have to. Right. Okay. Now just select A, B, and C, and I think we should just be able to right click and say plot and things like that. Right. So is there a plot? No, wait. Maybe it's under tools. Maybe it's under tools. Maybe it's under on top tools. No, maybe it's under data. Maybe it's under data. Create a graph. No, is there a create a graph?
Validation.
Wait a sec. Maybe insert graph. Oh, wait a sec. Someone should just Google quickly to say how do you create how do you plot
yeah, that would be great. Thank you.
Google spreadsheets. How do you plot data in Google spreadsheets?
Create a figure and plot data given two data vectors, X, Y. Open
Alexa, stop.
Plot the data.
Picked up. Someone should Google and say.
I believe it's under insert and then chart, if I'm not mistaken.
Is there a chart? Yeah,
chart. And then I think you can do customize. Oh, you have it already.
Where's the blue? Where's the blue? I can't see the blue at all.
I can only see the red one.
Yeah, because the blue is so fast. Well, actually, look at it. The blue is so
wait,
fast.
It's right there.
Right, because it's here. Okay, now it is worth talking about. It is worth talking about in the forums because now the blue, it looks like it's flat, but it's actually a line. Because we're going with such large numbers, the square of those numbers is big. We're looking at that side of the parabola. Now, if you look at from 0 to, let's say, 100, you'll actually see the blue very clearly in a slant, right? So I think we've got to repeat the test. Do we have time? Well, we have time. We can do this now. In fact, why don't you guys do it? Like, Josh suggested, right? Here is an exercise for you guys. You got to repeat this whole, you basically go back to that code. Maybe Reena can tag someone else and talk through this. Right? What you have to do is essentially reproduce the same thing, except don't go all the way to 1,000,000. What is our loop in our main?
Right here.
Time. Yeah, don't go to 1,000,000. I think just go to 100. Okay, just go to 100. And yeah, actually, if you go to 100, we should be able to see some decent, separation between the two. Oh, you only have 2 now. All right, now
that's all I got.
No, wait a sec. Okay, yeah, all right. Because you're doing n plus equals 10,000. Instead of n plus equals 10,000, you got to say n plus equals 100.
I still got one.
No, wait a sec. No, n less than 10,000. N less than 10,000.
Okay.
Oh, no, 10. No, n less than 10,000 will give you 10 of those.
Oh, okay.
Yeah. Even then, I think we won't get enough points, but we'll see. Right? Copy that into the Google spreadsheet, and we'll see if we can actually look at this itself, and we can find out. Now, already by No, I think this would be okay. Even then, it's very close to 0.
Yeah,
Very close to 0.
very consistent too. Oh, there's one.
Oh, what about right at the top? Right at the top. Is it 0.006 and 0.2? And this is well, go in steps of 1, maybe, right? Go in steps of 1 instead of 10. Go in
Why don't
steps.
we could just multiply the result by like 100.
No, it
Or-
won't work
or
because
10.
both of them will get scaled up. Yeah. You can try that, obviously, you can try that and see if it works. But I think if you go, no, instead of n equals 10, no, n plus equals 100, just say n plus equals 10. Yeah. Now, yeah, do that. Okay.
Same
Oh, right at the
thing.
top, right at the top. No, not at the top. We want to see at the top. We only want 100 points, in fact. We don't have to go, n less than 100 will do. N less than 100. And then n plus equals 1. N plus equals 1. And then n equals 1. N equals 1. Start with n equals 1. Okay. All right. Now I think this is the best we can do. We get 100 points. Okay. Now let's plot this. Let's plot this. Even then, you can see how much less efficient passing by copy is compared to passing by reference. Yes.
Mm-hmm.
Because it is taking copy of the whole thing. And in fact, if you find if you find if you fit a curve and say, that is quadratic, meaning it's a parabola instead of a line. Okay, you can find these relations and talk about them. It'll be more interesting, and it'll be a lot more.
Oh, okay. Now we can see.
But
Kind of.
it doesn't look right. It doesn't look right.
Yeah.
It doesn't look right. You got to fiddle with this. We're out of time, unfortunately. But here is a fantastic opportunity. There's a bug in it. I want to know if everybody understands what we're shooting for and what we tried to do today, because you are going to take this and fix this bug, and say, hey, what's going on here? We should get the two graphs that don't make sense, right? One of them should clearly take time that is proportional to the length, and one of them should be a line and the other one should be a flat or something like that.
Mm-hmm.
Well, that's what we were seeing in the first place.
Yeah, that was the
one
first
of them was a line and the other one was flat. That's what we were seeing. Yes.
Yeah.
All right. Okay. I don't know what I was thinking. Okay. I'm so sorry. Okay. One of them should be horizontal, which means it takes constant time. It's just being passed by copy. And the other one says it depends on the size of the vector. You give me a large vector, it's going to take, a long time. So it actually is like a line and the other one is flat. That's what we should see. That is what we saw. And I'm so sorry for wasting your time, chasing a, red herring here. Because it is doing what it should do and what we expect it to do. You can actually go from 0 to 10,000 like you had before, I think, and then talk about this and saying, hey, this is the effect of passing by copy versus passing by reference. Now, when you pass by copy, this is actually what happens. And the other thing, I have a few minutes and I'll talk about the, rounding off this computer architecture thing. It returns a value and, it says, oh, here's a double. And this guy should say, yes, that's a double. I'll unpack it like a double. That's fine. The other way in which the caller and the call function communicate is parameters. And the parameter passing is also important, just as important as the return value, because if this guy says, I'm going to call that function, I'm going to give you an integer and a double. And that person says, all right, I'm being called, I'm being given a double and an integer. That's all, okay? Same thing, but it's expecting things in two different orders, right? This is sending it in one order. That is, again, disaster. I got a balloon. Is it two of these? Yeah, I got a balloon, right? So that is, again, disaster, because this is saying here is 16 bits for an integer. And then that's, 8 times 8, 64 bits for a double, and it's pushing that on stack. That function, when it is called somewhere else in memory, says, I have been given two parameters. Where are those parameters? They're on stack. Let me pop from the stack. Get me the integer first. But that integer is only, so this guy says, here's an integer. That's on stack. Here's a double on top of that. So that's 8 bytes, 8 bytes for an integer, or 16 bytes for an integer. 8 bytes for bits and bytes, okay? So it's 2 bytes for an integer, 8 bytes for a double. On that side, it says, well, the double's on top. I want an integer first, so it takes the top 2 bytes of the double, treats them as an integer, and says, I've been given that as an integer. And it takes the bottom 2 bytes of the double, combines it with the integer, and takes those 8 bytes as the double. So you can see where's this confusion there? And that function will not do what is expected to do, and it'll crash. And this won't result in it'll result in all kinds of weird errors. These are things that you'll run into. That is the other reason why include files are so important, because in include files, we have the signatures of all these functions that you will call. Is there an include file, hash include vector, hash include IOStream? Why do we do that? We do that because the compiler is told in these include files. When someone calls cout, these are the things that cout can do. If they try to do something else, crap out and give them reading, right? When someone says vector.push, this is what the vector can do. The vector expects an integer as a parameter, but it's not being given an integer. So don't proceed. Just crap out. If you can generate machine code, that machine code will probably, crash or, fry the computer or something like that. So the compiler will have your back and say, well, I've seen the include file. I'm not going to do it. Yeah, so that is the function of include files, and that is the great value of forward declarations also. Now, I think today, in a kind of loose way, because I think I didn't plan as well for today's class as the previous class, I think we covered some important concepts, but they were kind of scattered all the way through. And also, we didn't manage to switch between multiple programmers today, partly because of my poor planning, but I think I'll get better at it next time. And also, I didn't get a chance to do what Josh suggested, which is to get to a problem and say, all right, you guys solve it. I'm going to step away, right? So I'm not going to be in your face. Hey, Josh, we'll do that next time, okay? Josh, are you here?
Yeah, I'm here. Okay.
Hey, well, remind me too, if I'm not doing that next time. I'll try and think of a problem on Thursday where you guys can code and I can watch. And I think it'll be more interactive and fun, okay? But in the meantime, take this, discuss it, dissect it, take it to bits, understand everything. If you don't have a clear view of something, just ask and say what's going on, okay? It doesn't only have to be about quests. People are only asking about, I'm stuck here in a questing issue. No, it should be about anything. So just talk about your own projects. In fact, Wes posted saying, hey, that thing sine wave should look like a jump rope or something like that. By the way, jump rope is not sinusoidal. I think the correct name of the curve is a catenary, because it has two forces, the gravity and the tension or something like that.
No, I just said a swinging rope. I was thinking of the ropes they use for exercising.
Yeah, but you know what? I think we can get the effect. But we can get the effect.
Yeah,
yeah. So if someone actually does that, it's actually very. We can do that too in a separate class. Outside of 2A, if you want to, 45 minutes to work through that, I'm happy to schedule a class. All you need to do is basically just model different points that are at different locations, angles like that, right? And then plot the y values. It's calculating the y values and plotting that. You'll get a very nice effect, just like Wes wanted, like the rope going around. I think we can do that too. When I read that, I could visualize that, and I thought it was a very interesting twist. Okay, so we can absolutely do that. Okay, but if you do that and share it, that is also fantastic. Okay, I look forward to these things. Very interesting posts, very interesting discussions you guys are generating. So please keep that going. And if you have any questions, absolutely, you should feel free to ask now. The next class, I promise, I will talk less, okay, and get you guys to code more, all of you together. Thank you, Rena. Okay, thank you, Rena, for also, staying a step ahead and also correcting a lot of things. I was making some silly errors here too, and hopefully you guys picked up on that before Rena corrected it. That is all important too, because it's important to see all the errors being made. Even by someone who's been coding for a long time, like me, right? I've been coding for a long time, but when I code, I still make errors, lots and lots of errors. And then that'll also give you an idea of the kinds of errors that you will make too with more experience. You'll see that, well, you know what, these kinds of errors get less with practice. But the stupid errors, they never get less with practice. Even after a million years of practicing, you'll still make stupid errors. But they're different kind, right? They don't cause they will cause frustration but it's not like the other kinds of errors, right? It's all fun. It's all part of the game. I just want you guys to enjoy it, okay? Just enjoy it and have great fun. And then on Thursday, we'll take this to the next level, maybe. We'll talk more about functions, and then we'll prepare for, next week, we'll talk about objects, or even review for the midterm. That's fine. If you want a class on Tuesday where you just basically ask questions about the midterm, not about the midterm, about topics that may be asked in the midterm, cover any of those, okay? We'll just make sure that everybody is ready and prepared for this class.
When is the midterm due?
It's
Is it-
on Thursday. Thursday, anytime on Thursday, week 6,
Oh.
right? Next Thursday.
All right, sounds good.
Before midnight, and you only have 1 hour. So don't start it after 11. That means you get less than 1 hour. But if you start it before 11 p.m., you get a whole hour.
Is that next week or this week?
Week 6, that's next week, yeah. And yeah, there are lots of resources. Andrew said he actually loves reading the book. It is a really fat book, okay? Even if you get the free version that Rena had posted, it is really fat. But if you enjoy reading the book, fantastic. Okay, all of the topics that will be covered in the midterm, or there's also, unofficial notes Michael Losef created at one point, distilling essential topics from the book. We don't host it at in the department. I think the division owns the thing, and I would not encouraged to share it. But certainly the CS Club has an unofficial copy of Michael Losef's notes. I mean, just see if you can get your hands on that. That will give you a very good distillation of the topics in the text that'll be important for the midterm. Yeah, we'll have another week to talk, another chance to talk about these things, so don't worry. I think you guys are doing great, okay? Just keep the same kind, just keep the activity level up, okay? And make sure that this continues to maintain that importance as your other subjects creep up. And Daniel said, oh, all these other classes now picking up. Yeah, well, okay, well, you should plan all of that too, and make sure that even though all the other classes pick up, you still have time for this. All right, okay, I'll see you guys on Thursday, okay? I hope all of you will come back. All right,
Good night.
bye.
Thank you, Professor.
Thank you. Have a great night.
Bye.
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 You too.